everyone is already working on their laptops. So yeah, maybe don't start with the workshop already. So just to give you a short introduction. Welcome to this workshop, building an enterprise data lake architecture on AWS. My name is Stephan Schiller. I'm a solutions architect at AWS. I joined AWS 1.5 years ago, and my main focus is on analytics workloads in AWS. I'm mainly focusing on streaming services like Kafka and Kinesis, but as a solutions architect, we need to cover like the whole bandwidth of AWS services. And yeah, with me is Alena today. She will later talk about different other aspects or services of this workshop. So this workshop is, like, the main purpose is that you get hands-on experience with the AWS services. In order to make sure that everyone is here on the same page, we have a few slides, but not many. This is really about you going through certain labs, getting hands-on experience, and yeah, just getting your feet wet with AWS services. Before we start, here is a short agenda how we will proceed in the next 3 hours. At the beginning, as I said, in order to make sure that everyone here is on the same page, we will start with a short introduction about what analytics on AWS means. So why is analytics even important? Why is it good to do it on AWS in the cloud? What are the advantages of it? And then we will start with the account setup. For those of you who don't have a laptop with, maybe it makes sense to you maybe join forces with others who have a laptop and proceed on the laptops with them. Because as I said, like, the main purpose is really that you go into the labs. They are pretty much self-explained, so there's not much to say about it. If you got questions, just raise your hand, we will come over, we can do it together. If you got questions, just ask. So after the account setup, that should take a few minutes, we will go into the first lab. This is about like how you can ingest data into your data storage, like your data lake, and how you can set up your data lake. Then Alena will talk about how you can set up an ETL pipeline, how you can do analytics, how you can visualize your data using dashboards in Amazon QuickSight. And then you will do exactly that. You will, in the labs, you will do exactly that what Alena talked about, like building up a data catalog, setting up an ETL pipeline, and then in the end, doing analytics and visualize the data with QuickSight. At the end, we have 15 minutes for FAQ and an open discussion. But as I said, feel free, just raise your hand. We can also talk about things that are maybe unclear. Maybe a personal recommendation from my side is take your time. Like, don't rush through the labs. You have now 3 hours, that's more than enough. Take your time, read through the lab, try to understand what you're doing there. It's way better than just rushing through the labs and try to finish as fast as possible. Any questions? Cool. For those of you who just joined, I just said it's very important to have a laptop. If you don't have a laptop, maybe join forces with someone who has a laptop and then look together on them. We will set up the workshop in a few minutes, like after the first presentation. And yeah, then I would say, let's directly jump in. A short question, who of you is familiar with AWS? Who has experience with AWS and running AWS workloads already in production? Oh, like half of it, I would say, 30%. So that's good. We will start from scratch. So for those of you who don't have experience with AWS, we will start from zero. And this workshop, as I said, is especially also for people who don't have experience with analytics. And maybe the second question, who of you runs analytic workloads on AWS? 2? Okay, that's good, that's good, that's very good. So that's the intention of this workshop, so that you can start from scratch and get experience with it. So analytics on AWS, why is analytics important? Why should we even bother about it? And why does it maybe make sense to run it in the cloud? There are a few reasons for this. The first one is data grows. Like in the past decades, data grew from terabytes to petabytes to exabytes amounts of data. And in traditional on-premise environments, we had, of course, the issue that it's very hard to scale in on-premise environments. So the hardware is pretty expensive, and then you need to adjust to the ever-growing data. And then secondly, we have what goes hand in hand with the first trend is that you have more and more data coming from more and more data sources. So you have your ERP systems, your CRM systems, Salesforce, SAP, etc. More and more data comes from IoT devices, social media, from your smartphones, etc. All of this data needs to be captured. And with that, the data also gets increasingly diverse. So you have many different data formats nowadays, like compared to 20, 30 years ago, where you have your structured data, so your relational data that is like very homogeneous. You now have a set of, or a variety of different data formats that a company needs to handle, and the infrastructure needs to handle. And the fourth and the fifth trend is that more and more people within your organization want to have access. 30 years ago, like your IT department needed access. Now you have all the different business users, the different departments who want to have access. You have your data scientists, you have your data analysts, etc. And lastly, all of these people use a variety of different applications to analyze the data. So we don't have like one application that accesses your data. You have a set of different tools, each are specialized on a specific task to analyze it. So how do you make this data then accessible to these applications? So we transition over to a modern data platform approach. So 30 years ago, 20 years ago, data warehouses were pretty famous. Like in the 90s and early 2000s, we had data warehouses who could scale pretty well, but they only could store structured data. So companies set up all the different data warehouse silos in order to handle the huge amount of data that came up. But there's like a downside to it if you have many different silos. First of all, it's pretty hard to do analytics on data that sits inside different data silos. It's pretty expensive also, and it's pretty hard to manage these different data silos that are living across the organization. So you need to make sure that all the people who want to have access get the right access to the right data. So you still want to establish a least privilege model to make sure that only the people allowed can handle or access the data. And then we transition over to the right part here. So having a central place, a data lake, where you have a central place, a central repository to access the data. And here in the data lake, and we come to this, like the typical characteristics of a data lake is that you can store whatever data format you want to have in there. It can be Apache Parquet, it can be org, you can store CSV files, JSON files, etc. It doesn't matter. And then you have all the services around it, like relational databases, non-relational databases, some kind of a data warehousing solution in place that need to access the data lake. And please don't get me wrong, this is not about that a data lake replaces a data warehouse. So data warehouses have still are still relevant today to use. They are just maybe a different place and not in the center of your modern data architecture approach. They are like one component that fits into it. So what are the advantages if you use, like, if you have a modern data architecture with a data lake inside it? So you have your scalable data lake, and then you have all the different tools around it that you can use, where you have, let me go one step further. You have all the different things, and this is maybe just one slide that I want to emphasize on, where you can use, that emphasize on the different AWS services that you can use. But today it is about the AWS services, but this slide is more about showing you there is one application or one tool, one set of tool that fits for each task that you have. So there's no silver bullet that solves all of your problems. So if you want to have a relational database, you can use, for example, Amazon Aurora. If you want to have a non-relational database, you could use DynamoDB. If you want to run machine learning workloads, you could use Amazon SageMaker. So for every task that there is a tool that can help you. And we will show you later an architecture that you will deploy within this workshop, but please don't get overwhelmed by it, by like all the different logos and all of the different services that are out there. They should just ease a little bit your life and make it just a little bit easier to set up all the analytics workloads because, as I said, there's no silver bullet, one tool that solves all of your problems here. So let us start with the data lake itself. The data lake on Amazon, on AWS, will be deployed on Amazon S3. This will be the tool, the service that you can use to save and to save your data and have your central storage that acts as your data lake. So what is a data lake? So a data lake is a centralized repository that stores all of your structured and unstructured data, all of your relational and non-relational data, and you store the data as it is. You don't transform it, you don't change it, you save it inside your data lake as raw data. And the huge benefit of it is, if you use a data lake, is, as I said, it is very easy and very simple to ingest the data inside your data lake. So you don't have to think about how you need to transform it in order to save it there. It scales to, let's say, infinity. So it's for you, if you use S3, for example, you don't have to think about how you scale your data lake. And then you can use all the open table formats that are out there. If you have experience with it, Apache Iceberg, Hudi, Delta Lake, you can use all the open table formats that are out there. And this gives you the huge advantage that you now decouple the storage from the compute layer. So you can easily transform or move the storage away to another compute layer, what makes it less expensive to move the data between different compute resources. So how does this look like if we think about it from a native flow, native data processing flow? So here on the left side we have all of our data sources. So your systems of records, these are all of your CRM systems, ERP systems, some high quality data that comes out of these systems, like your customer data, your orders, your product information, etc. When you have your systems of engagement, these are typical like events that you capture that are about like when a customer places an order, for example. And then you have sensor and log data, typical IoT devices, data from different sensors. These data flows normally through a streaming service like Kafka or Kinesis. And then you have external data that you don't have any influence on, like any third party or SaaS service where you just get an API that you can trigger, pull, or push data out of. And then on the right side, we have the consumers. These are data scientists, people who need access to the raw data. Then you have the data experts, the business users, people who need consumable data that is already transformed that they can work with. And then you have all your downstream applications and your applications that need some kind of a data format like a JSON file to process the data. And then inside you have your data lake that we just talked about here deployed on Amazon S3. But what happens inside this data lake? How does data flow inside your data lake? How does it flow out of your data lake? And let's have a look don't look at the AWS services, just look at on how this data flows between or inside and outside of your data lake. So we start with the raw data. So the data that comes into your data source, you need some kind of a service who moves the data from your data sources inside your raw data. Then you have your prepared data that is refined data, it is cleaned, it is deduplicated, it is combined with other data maybe. And then you have your consumable data that is very app-specific or use case-specific. So you need to combine it or change it in order that the downstream application can use it. And these are now, and this should just show you that there are all the services out there that can help you in each part of this data flow. So as I said, we will not cover all of the services here in this workshop, just a few of them. But this is just to show you there is a service out there that can help you with like setting up a security model, a compliance model, moving data inside your data lake, consuming data, preparing data, cleaning it, etc. And we will find that out in the next 3 hours. Some of the data, some of the services you see here are not only for analytics workloads. Like all the security services that you see here, IAM, KMS, or if you use CloudTrail, these are services that are not specific to analytics workloads. So this is just an example of an end-to-end data architecture that you should be aware of. But there is a risk if you don't have all of these services. So if you only have a data lake. So if you only have a data lake and think that's it, there is the risk of a so-called data swarm. So a data lake who doesn't have any sort of mechanism how you can make the data searchable, how you have like a data lake in place with a catalog where you can look for your data, or a governance model to make sure that the right people have access to your data. So this is something that you have to be aware of. It's not enough to just deploy your data lake, your S3 bucket, and say that's it, because it's very easy nowadays for companies to push data inside your data lake and then say that's enough for me, that's like people can now query the data and have access to it. You still need to make the data searchable for your users. You still need a governance model. You still need a data and ETL pipeline to transform the data and make it like getting information out of it. Because collecting data is one thing, getting information out of the data is another thing. And that's where we talk about the purpose-built data services. So outside of the data lake, how you can use all of these different services, set them up, and then make sure that all of them connect with each other. So before we start into the workshop, and that's enough with slides, is just what means serverless, because you will set up a serverless data lake today. So serverless is just a native approach, how you deploy things, how you will use things in the cloud. So it's the native architecture, how you use it. There are a few characteristics of serverless. It just means that you like switch the responsibilities or shift the responsibilities over to your cloud provider. In this case, it's AWS. One characteristic is that you have high availability in place. If you use, for example, S3 as your data lake, you will have high availability already built in. So your data lake will be deployed across a minimum of 3 availability zones. If one availability zone goes down, you don't care, the other 2 jump in. You will not even recognize it. A second characteristic is that you have a built-in billing model. So the billing model is that you only pay for what you consume. So you pay for the storage of your data lake, of the S3 bucket, but you don't need to pre-provision the storage for it. So your S3 bucket scales with you, and you only pay for the storage that you consume. And the third characteristic is the automatic scaling. So you don't have to take care if the traffic rises, if you need more storage from your data lake, you don't care, the S3 bucket scales automatically for you. So now let's have a look how the workshop is structured. I already talked about it. In the first lab, you will see how you can ingest data inside your data lake and how you can set up the storage. And then you will do the other 2 labs, but this will be, we will discuss when it's the time for it. That's the architecture you will build today. Some of it will already be, there's no pointer. Some of them will already be deployed, like you don't have to care about the Cognito user pool and the Lambda functions. This is already deployed. So we will today deploy like your Kinesis data firehose for streaming the data inside your data lake. You will set up your data lake, your Glue ETL pipeline throughout the 3 labs. So just one word to how you can ingest data inside your data lake. So there are many different capabilities or possibilities how you can ingest data inside the AWS cloud. If you have huge amounts of data, you could use a Snowball family, what are like really physical devices that you put inside your on-premise environment, load the data in it, and then shift it towards AWS. You could use network connectivity with AWS Direct Connect to use to just send data over a private connection to your AWS environment. Or if you want to stream data in it, you could use the Kinesis family. And the Kinesis family, we will only, as I said, today focus on data firehose. Kinesis data streams is something similar to Kafka. It's a little bit easier to set up. Data firehose is for preparing and loading data, transforming it on the fly and saving it or streaming it towards your data lake, your data warehouse, etc. And the other two will not be covered for today, data analytics and video streams. So for today, you will, in the first lab, as I said, deploy your data firehose and set up your data lake and your storage. And just that you can see how this fit into the previous slide we just talked about. These are the services, like setting up the storage for your raw data and how you move the data from the data sources inside your bucket. And that's it. This is the workshop link. You should get direct access to the workshop itself. You just need to provide an email address. And then you will get a code and can access the workshop itself. If you got problems, just raise your hand, we come over. And yeah, also the Wi-Fi password.
Everyone. I think you should have all reached the end of Lab 1 by now. So let's take a quick break for the hands-on part. So I know probably you want to get moving also on the second lab, but let's take a quick break because I'm just going to explain you some of the services that you will be using in the second lab so you know a bit more what's happening under the hood and what you're actually building and maybe why you're especially using these services. So this is what you guys have built now, right? You have ingested some streaming data, some sample data with the Kinesis data firehose service into a raw S3 bucket. And this for now constitutes your data lake. So this is where the data resides. So that was a very full slide, so let's abstract it a little bit to a bit more easy architecture overview. This is what you have. You have your Amazon S3 bucket, that's an object store. We heard before S3 is great because you can basically just dump your data in if it's structured or unstructured data and then leverage that for the further processing in your analytics pipeline. Now, you have your data in S3. You were able also to run a select query on a single file. Maybe that's important to note. This S3 query select functionality you guys used, this is only for single files. Now, that's not very practical, right? I mean, normally you wouldn't just want to analyze a single file. In a data lake, usually you have thousands of files. If you kept your data generator running, you will also see a lot of files popping up in your S3 bucket. And naturally, you want to kind of query them per partition maybe. So maybe you want to query the streaming data of a specific day or of a specific hour. And the service that will help you do this is AWS Glue. And as the name suggests, it kind of glues together all the pieces of your ETL pipeline functionality. Now, why do we use Glue? Maybe quick activity, quick show of hands. When you think about ETL jobs, so jobs for extracting, transforming, and loading data, how many do you think are still hand-coded today? So maybe quick show of hands, who thinks it's around 50%? Okay. Who thinks it's like 70%? Okay, some more. More? Okay, one person raises their hand. It's actually the 90%. So we see that today still over 90% of all the ETL jobs that are being performed are hand-coded. Now, there is a good side to this. It gives you a lot of flexibility. You have the full control over the job. It is very well integrated with your CI/CD pipelines, your developer tools. However, of course, there is kind of a but here as well. This is very error-prone, right? We're all humans, we do mistakes. And even if you are super thorough in the programming of your jobs, what happens if maybe your source data changes? Because that is also the idea of a data lake. You just ingest your data, so maybe you don't even notice if the schema of the data changes, and that can completely break your whole ETL pipeline. And of course, you don't want that happening in a production system, right? So that's why Glue is offering you a way to automate this and make this a bit easier. So Glue is a ETL platform that has a lot of features to support you with your ETL jobs. And so that could be, for example, transforming data, but cleaning data, and then also compressing it again into, for example, columnar-oriented file formats like Parquet files that are very well optimized for analytics queries. The main components of Glue you see kind of at the bottom here. So at the very center, and you're going to hear me mention that feature a lot moving forward because it's really at the center of Glue, is the data catalog. So the data catalog is a metadata repository that gives you an insight on what is actually there in your data lake. We heard before the concept of the data swamp, right? You just dump everything in, and then you basically have no idea how to access the data because you don't know what's the format, what data do I actually have in my data lake. So this is where the data catalog comes into play. It gives you an overview of where the data lies and what is the schema of that data in these in a specific S3 bucket, for example. We will also set up a data catalog in the lab moving forward, and you might see the notion of a table pop up in the data catalog. Now, it's very important to note we're not moving any data here, right? So it's not a table in the sense of a database table where you would load data into. It's just a metadata table, so maybe just as one thing to keep in mind. And then, besides the data catalog, Glue also has an ETL engine, so it allows you to author jobs. It has a lot of transformers that you can leverage out of the box. And then it also gives you scheduling features, so you could run an ETL job maybe kind of like a cron job, and it helps with the optimization monitoring of that jobs as well. Okay, let's look at some of the key capabilities, so a little bit more detail. I'm not going to go into the bits and bytes here, but just an overview of 4 important pillars. So on this side, you see that Glue gives you this ETL engine, and I already mentioned some of these built-in transformers. So this is pretty neat because it helps you to not reinvent the wheel, right? So there's a lot of transformations on data that you usually want to perform. So that could be something like dropping a column, could be maybe renaming a column. So a lot of these more basic things. So instead of you having to kind of build this by yourself, Glue is kind of taking care of this. But it can also be some more advanced features. So another transformer that Glue, for example, provides is the identification of sensitive data. So oftentimes, you might work with a data set that's not like dummy data as we work with in the lab today, but usually you have certain items in your data that maybe has the names of people, I don't know, an IP address, an address, just things that you maybe don't want to have in the data set that you leverage for analytics because it's not really relevant for the analysis that you run, so you want to be very mindful of data security here. And Glue gives you that option through a transformer to automatically identify these sensitive items in your data and redact them. So you can, for example, just replace them with asterisks. Then if we move to the second pillar, here we have it again, the Glue data catalog. So this is really here to help you also with the whole data governance. Because you can only do data governance if you know what's inside of your data lake. And this plays then also closely together with another service. Unfortunately, we don't have time to go into too much detail on this today, but it is called lake formation. So this basically allows you to set permissions on your data lake, right? That's a bit more challenging than maybe in some other architecture types. But with lake formation, what you could do, you can give columnar, row levels access, and even cell level access. So maybe different business analysts should only have access to parts of your data and don't see the full thing. So this is then possible by a combination of lake formation that kind of builds onto your data catalog that you have in place. There's also other things you have with Glue, like a data quality, where you can define certain rules that your data should adhere to, and then it gives you a score. How good is the quality of your data, so you also see if it's degrading, and you can take certain actions. One more to the side, the third pillar is actual connectivity to your data. All these transformations are like no value if you can't connect to any data sources. So of course, Glue has a lot of inbuilt connectors, that is to AWS services, but even third-party services, like Salesforce, for example. You can also connect to and run your aggregations, cleaning data jobs on as well. If you don't find the connector to a product, a service that you want to integrate into your pipeline, there is also the Glue connector marketplace that has a lot of additional connectors that you can use. This is usually for SaaS, so software as a service offerings. And then on the far left, I think right from your end, we have the user productivity and data ops features. And the idea here is that we want to make Glue available with the necessary features for different personas, because we realize that a data scientist and a data analyst, they might have different requirements when working with ETL jobs or data in general. So let me just show you how that actually looks like. I think that's a bit easier to understand then. On the left side, we have what data engineers would normally use. So this is more of a low-code environment where you can have kind of a visual, or where you have a visual interface, if you like, and you can just pull in the different transformations, your source definitions, your destination, as you like into the job, and make it as complex as you want. This is also what we will see in the lab moving forward. In the middle, if you want to get a bit more like hands-on, if you want to code, you can do that with the notebooks and the interactive sessions. These are also pretty nice if you want to debug, but this is again a bit of a different type of persona that would leverage this feature. And then on the far end, we have the Glue Data Brew feature. This is a real no-code solution. So for data analysts, anybody that wants to pre-process data, doesn't want to write a line of code, this is kind of the solution to go with. It has a visual user interface where you can also perform certain data modifications, you can perform cleaning on a specific data set, and then you can transform the actions you took. So maybe you deleted a column and renamed another, and you want to do this for future data sets as well. Now, of course, you don't want to run that manual process all the time, so Data Brew gives you the opportunity to store kind of the actions you took in a so-called recipe, and then you can just apply that for future jobs. And these recipes, for example, could then also be plugged into the Glue Studio, and other colleagues on your team would also be able to use them moving forward. Okay, so looking at our architecture, we have the S3 bucket with our data, and now we actually see what's in there. So we get an overview of the partitions we have in the data lake, and we do this through storing that metadata in our data catalog, and we populate the data catalog through a crawler. So the crawler will just run on our S3 bucket and gather all the necessary information on the schema. Okay, cool, we know now where our data is, but we still don't really work with the data. So here comes the fun part. Here it comes. Amazon Athena. So this is the service that really allows you to then run queries. There are other services as well that you can use in combination with Glue and to perform certain analytics queries. But for today, we're going to focus on Amazon Athena. And I just want to give a bit of an insight onto that service. By the way, any one of you has used Athena in the past or is aware of that service already? Okay, a couple of hands, perfect. So for those of you that already know the service, I hope you learn maybe a bit more. For those that don't, here comes an overview, so you're well prepared for the upcoming lab. So Athena is an interactive analytics engine, and it is based on Trino and Presto. So it kind of is a managed version of that on AWS. And what it does, it is perfectly suited for ad hoc queries on data. So think, for example, you want to build a report once a day every 3 hours or so, and you don't have any long-running analytics queries, Athena is the service that really helps you do this. And the nice thing with Athena is it is a serverless service again. So here we come back to that notion of serverless. Now, why is that beneficial for your architecture? You do not have to manage any infrastructure. So that's why Athena is also kind of ready to use. Directly, you just plug it into, connect it to your S3 bucket, and you can run your initial queries. And that's why it's like customers really like to use it. It's very simple to leverage. So let's look a bit more into depth into these 4 aspects here. I already mentioned you have that instant start with Athena because of its serverless setup. Basically, you define what is the source you want to query, and you go ahead. Also, Athena is not only able to query data in S3. So I only talked about S3, but it actually allows you to query data across different data sources. Why is that interesting? Oftentimes you have your data lake in S3, but you might still have certain other parts of your data, maybe in a DynamoDB table. And then you don't want to duplicate data, but you just want to query it where the data resides. And this is where Athena really is powerful and supports these so-called federated queries. So in practice, what does it mean? You could, for example, join 2 data sets from different sources in a SQL select statement. And then you would, for example, join on data in S3 and data in DynamoDB, but be able to run your query on that combined data set. So this is very powerful also for aggregating data for the further steps in your analytics pipeline. Athena supports languages that you're usually already familiar with if you're working in the data analytics domain. So it supports SQL, also supports Spark. So there's a lot of features you can also leverage for optimization with Athena. Of course, it also supports compressed files. It can work with the open data format. So it's really a state-of-the-art service here. And lastly, of course, also important when thinking about architectures on the cloud is the cost. Athena, again, is a pay-as-you-go service, so you only pay for the things that you actually consume. In the case of Athena, this means the queries you run. Basically, you're only being charged for the data that you scan and the query like numbers that you generate. And you can be you can optimize this a lot when you think about partitioning your data. Because normally you don't want to query all the files in your S3 bucket, right? Imagine you have that data generator that we run today, you keep it running for a month, and you just want to look at the data from today maybe. Then if you do not partition your data, you would have to scan all the files in your S3 bucket, you would have to pay for that as well, and it's just gonna run quite, not super long probably, we don't have the terabytes of data here. So that's why normally you would have partitions, as we do, you all guys have these in your buckets for now, partitioning by the year, month, day, I think even the hour. And then when in Athena you run a where or an SQL query with a where clause, Athena takes care that it only scans the data in S3 that apply to this where clause. So we already talked about I always need to switch my vision when I look at this. On the left side, so we talked about this piece. Athena connects to these different data sources, and you can also query across the data sources with the federated queries. Now, what happens on the other side is that you can then leverage these queries that you run with Athena for kind of the last step in your pipeline, which is actually where you generate the value for your end users. And that could be displaying the results of these queries in a BI tool. We're going to come to that service in a second then. But what we also see, increasingly more customers actually leverage this to kind of join sources for their training data in ML flow. Even for highly complex inference jobs, Athena becomes more and more relevant as well. All right, let's look where we stand. So we are now able to query actually the data that is residing in our data lake because we know how the data is stored there, what the schema is. We can run SQL queries on that data. One thing, by the way, I didn't mention, neither Glue nor Athena move data. So the data always resides still in the S3 bucket. the data will not move anywhere, right? So if you run a SQL query from Athena, it will just run this ad hoc query on the data source, in our case S3. Now, we also want to build something visual, so actually look at the data, not just get the output of a SQL query. I mean, you could do that, but what's the fun in that? So in our case, we add a BI interface to this, and the service on AWS that allows you to do this is called Amazon QuickSight. So this is a managed BI service. There's not so much to explain with QuickSight because it's super visual, so it's much easier to understand maybe than the other services, but just a quick outlook. As I mentioned, QuickSight is our managed BI service, and the idea here again is to enable BI usage across your organization for different users. There is 4 main features, ways of using QuickSight. The first, and I think that's also what most of my customers normally use, is the use through dashboards. So that's what you're kind of used to also from similar solutions like Tableau, if you have used that maybe in the past. So here you can build dashboards. Those can also be interactive, and you can share them with your users. Those could be internal, external. There's a lot of options on how you can set this up. Then we can also augment our analytics, right? At the moment, Gen AI, everyone's talking about it. Of course, we have to mention this at least once in this presentation as well. But even before the whole Gen AI topic came up, QuickSight already had some machine learning integrations. So why is this actually interesting for a dashboard? So that could be for simple things like you want to calculate a forecast, right? So you have historical data, and then in your dashboard, you automatically want to display a forecast, maybe on your sales numbers or whatever data you have. So this can be done out of the box with the ML-powered feature in QuickSight. Now, luckily, we have these LLMs available, a lot of them to choose from. QuickSight also builds on this with the Amazon Q feature, and then under the hood uses large language models, for example, to generate a description of what is actually displayed in your dashboard. You could even just type kind of what type of diagram you want to create, and it's automatically created for you. And you can also offer natural language queries to your end users, so that they can just like search for, let's say, how much higher have our sales numbers been this month compared to last, and then you will automatically get this overview. We won't see that in the lab today because unfortunately we don't have time. But if you want to see that working, I can highly recommend the link up there. You will have some working demos. This is actually a pretty nice overview of working QuickSight dashboards. So you can take a look at that later on and just explore some of the features of QuickSight that we don't have a chance to talk about today. Coming back to the ways of using QuickSight, so we still have 2 left to talk about. The third is the paginated reports. So this is normally interesting for independent software vendors, ISVs, or enterprises, where you maybe want to create a report on a weekly basis that should be sent out through email, uploaded to S3, up to you, and this feature is also possible with QuickSight. And then lastly, maybe you don't just want to have a standalone dashboard, but you want to actually embed it into your own application, then you can also do that. Okay, I think that's almost the last slide, and then you can go back hands-on and kind of explore these things yourself. Just a quick overview of how the QuickSight features fit into the overall architecture of QuickSight itself. So for QuickSight, again, we have a lot of data sources that are supported. In our case, we would query these sources through the Athena integration, but you could also just like connect from QuickSight directly to some on-premise data sources or sources that you have on another provider, so this is also possible. Then what we have is the opportunity, or different 2 options actually, how you can access the data in the data sources. So you can either use the SPICE engine, and I just quickly need to look up what it stands for because I always forget. So SPICE stands for the Super Fast Parallel In-Memory Calculation Engine. So pretty cool name, and it's actually a cool feature as well. So the SPICE engine allows you to speed up the performance of your queries because it then supports this in-memory calculations. If you don't want to do that, no problem. You can also just run the queries directly on your source data, and that's normally also very performant already. So now we have the connection to our source data. Then we can go with different analytics features. I already talked about that, so I'm not going to go into too much detail again. But I mean, you can display your data you already have. You can do analysis on past data, doing a forecasting. And if you have your own machine learning models that you want to use for inference, you could even connect to Amazon SageMaker if they're running there, and augment your analytics or your BI through that. At the end, I mentioned the idea of QuickSight, again, is to cater to different personas. So different users have different ways of interacting with data. So that's why you also have these different options that we saw on the previous slide, either reports or maybe even some natural language queries. And then what that gives you in the end is basically opportunities maybe to build new products into your offering, or just in general modernize the BI in your organization or consolidate different BI tools if you have those in a bit more of a silo setup. All right, let's go back to the labs. So here is where we stand now. You guys finished the lab 1, so now you have still 2 labs to go through, and in those you basically will build what I just showed you. So you will build this architecture of the serverless data lake analytics pipeline, having data in S3. You will connect that with Glue, query through Athena, and then build a dashboard with QuickSight. So these are labs 2 and 3. Just to quickly show you again where we are in the terms of that architecture we had seen in the beginning. So that was the outcome of the lab 1. In lab 2, you won't do the Kinesis data analytics, but you're just in that processing stage. So you will go with the Glue service and store the transformed data back into S3. And then looking at the overall architecture, this is kind of where we're adding the data processing layer into the picture. And then in the last lab, this is really for the visualization part, we will add Athena and QuickSight into the mix. And then these should be, where are we? Yes, on this side. So this is really the insight consumption, working with the insights that you generate from the data in your data lake. Okay, so, sorry, not yet. You can rate us at the end. All right, I just stay here. So you guys can go ahead now, back hands-on and run through the lab 2 and 3. And as before, just let us know if you have any questions. Any questions on the presentation, though, for now? It's not working? Oh, no. Oh, okay, interesting. Yeah, I'll update that. In the end, we actually have a link to a landing page where you have also additional links, so it will be there. But I can just fix that and share with you.